Inequalities, two variable inequalities. It isn't as easy to see solutions in two variable inequalities as it is in one variable inequalities. This is why we almost always represent solutions for them graphically. We're going to be focusing on two variable linear inequalities in this unit, with a special emphasis on inequalities of the form y equals mx plus b. And I wrote equals, but with an inequality there instead of the equal sign. When we have either of these two, y is greater than or equal to mx plus b, or y is less than or equal to mx plus b, the line will be solid to show that all the points on the line are solutions to the inequality. When we have y is greater than mx plus b, or y is less than mx plus b, the line will be dotted to show that all the points on the line are not solutions to the inequality. Like one variable inequalities, we can use a test point to determine or verify what part of the graph should be shaded. So we're going to look at this example right here. If we had y equals mx plus b, this plus 2, that would tell us that our y-intercept was at 0, 2, right there. And then we'd use this slope, negative 1/3, which says go down 1 and to the right 3, and there's another point. Down 1 and to the right 3, and there's another point. So I would have points here. And it could also be up 1 and to the left 3, and there's a point, and up 1 and to the left 3, and there's a point. So we have those. Now, as I said, there is no equal sign here. So this is going to be a dotted line that goes through these points, and it extends beyond them. Now, because y is greater than, we know that we are going to shade above the line. And I can verify then using a point, a test point. So I'm going to use the test point here. I often use 0, 0. The only time I won't is if the line is on 0, 0. Then you cannot use that test point. So we have 0 is greater than negative 1/3 times 0 plus 2. All right, and so here on the left, we have 0 is greater than. This becomes 0. 0 plus 2 is 2. So 0 is greater than true. That's not true. That's false. So that means that the point 0, 0 should not be shaded. So we shaded correctly. That's how you can use a test point to check your solution. Next, I'll show you how to use a test point to determine where to shade. All right, so here we have, oh, this is not in y equals mx plus b form. Well, let's convert it into y equals mx plus b form. It doesn't take much work. Not equals, there's an inequality there. I'm going to add y to both sides. So I'll get 2x is less than 5 plus y. Now I need to subtract 5 from both sides. And when I do that, I get 2x minus 5 is less than y. Now, this is kind of backwards. We wanted it like y equals, except for not equals, y equals mx plus b, but our y is on the right side here instead of on the left side. That's okay. We can just completely switch it around. But when we do that, we need to make sure that we change this less than sign to a greater than sign. So we have to switch the direction of the sign. But that's all. And now we can graph. Oops. I also, here's an equal to. So I dropped that equal to. Hope you didn't. So my y-intercept is -5. Right there, 0, -5. And my slope is 2, so that means go up 1 to the right 2, up 1 to the right 2. And I can just follow that pattern. Now, because I have an equal sign here, that's going to be a solid line. Now I'm going to use the test point, 0, 0. So I'm using this point right here to determine where to shade. So now we have a 0 is greater than or equal to. This makes a 0, so we have -5 left. 0 is greater than or equal to -5. That is true. So that means that we shade on the side of the line where that point is. So this point's right here. When we plugged it into the inequality, it came out to be true. So that's the side that we shade on. So all of this over here is going to be shaded. And if you do not have a highlighter, which I like to do my inequalities using highlighters. If you don't have one though, you can do something like this. You can say, all right, we're shading all this over here. You could just make these arrows to show where your shading is occurring. And that is two variable inequalities.